Saxon's Trig, Lesson 28, Factorial Notation and Abstract Rate Problems, begins on page 193. Factorial notation is one of the simplest concepts you encounter in math. And a factorial is written as an exclamation point, and it will typically have a number in front of it. So if I said 3 factorial, what I mean is I want to multiply starting with 3, every number down to 1, and then stop. Of course, if I multiplied by 0, I would erase everything I had just done and keep the 0. And I don't want to throw negatives into this mix. So factorial means to multiply every number. So if it were 5 factorial, as we have in example 1, it means to multiply 5 times 4 times 3 times 2 times 1, and however you wish to do that. 5 times 4 is 20, times 3 is 60, times 2 is 120, so 5 factorial is 120. Now, you do not have to do them manually, because if it was a large number such as 100 factorial, you would end up having to do an awful lot of writing and an awful lot of multiplying. Your calculator does have an exclamation button, a factorial button, and you just need to figure out whether your calculator wants you to put in 5 and then the factorial, or the factorial and then give it the 5. But whichever way it works, your calculator should then spit out 120 degrees for that. In example 2, they want you to do 9 factorial over 3 factorial and 5 factorial. So I'm going to not use the calculator and manually do this, although you can practice on your calculator. So this is going to mean 9 times 8 times 7 times 6 times 5. I'm going to stop there because I see that in the denominator I have a 5 factorial, which means in the bottom I'm going to have 5, 4, 3, 2, 1, and they're all going to cross each other off. So I don't even need. So actually when I write it, I go 9, 8, 7, 6, and stop at whatever the largest number is here. Now I still have the 3 factorial, which is a 3, a 2, and a 1, and then I reduce whatever I can. So I see that 3 times 2 goes back to 6, and that can cancel off with this 6. So I'm only going to do 9 times 8 times 7, which is 504. Example 3, same concept. We have 14 factorial over 6 factorial and 11 factorial. So I'm going to start with 14, 13, 12, and then my 11 and down are gone, which means for here I'm keeping 6, 5, 4, 3, 2. I ran out of room, but you know that there is a 1 there, not really changing anything. So I look for whatever I could reduce if I'm not using my calculator to do it. So 3 times 2 is 6. 6 goes into 12 twice. The 2 can go into the 4 twice, and you may see things that I'm not seeing. 2 can go into the 14 7 times. 7 and 13 are both prime, so I probably can't do anything there. And then that would leave me 6 times 5 on the bottom, so 91 over 30 is not reducible. Example 4, use the factorial key on your calculator to help evaluate 11 times 10 times 9 times 8. So what would you want to do on your calculator? Well, you know that it's starting with 11, so you're going to do 11 factorial, but you do not wish to keep any of the bottom numbers from 7 down. So you want to divide off by 7 factorial. So again, depending on the order that your calculator wants things, you want to give it the 11 factorial and get an answer from the calculator. Then you want to divide by the 7 factorial, and when you hit that equal, usually calculators don't want you to hit equal twice, but if yours happens to just give the answer for 7 factorial and then the divided answer, you figure out how your calculator wants it, and you are looking for the answer 7,920. Part B is abstract rate problems. Now, rate problems we did in an earlier lesson video, and we already know how to deal with the rate. So when we were working on them before, the basic formula was rate times time equals distance. We had that other one that was rate times time times people equals jobs, but in this set, we're not dealing with the people part. So example 5 says the train traveled m miles at p miles per hour. Okay, here's the key with these. They're not typically going to give you numbers. They're going to be giving you letters. They are practicing, do you truly understand the concept of how to plug into this formula? Do you truly understand the concept of how to manipulate, solve algebraically to get the correct answer when you're dealing with letters and not numbers? Students don't like it, but you are fully capable of doing it. So the train traveled at m miles, that's my distance, at p miles per hour, that's my rate, and arrived an hour late. So let's solve for the time, the piece it didn't give me. So time should equal m, divide by the p to remove it from that side and get it to the other. All right, now let's stop and think logically for a second. If this were a number, let's say 5 hours, and 5 hours is arriving an hour late, I would want to arrive in 4 hours. So the key here would be to subtract 1. So in my time, I want my time to be m over p minus 1. That's a unit stuck together for the time piece. Now, how fast should the train travel? It wants to know a new rate, and this is what we're solving for, to have arrived on time. Did we make any change to the distance traveled? Nope, we just want to shave an hour off the time. So the distance is still m. Now we're solving for the r. This needs to be made into one fraction so I can flip it when I divide. So the common denominator is p. That changes this to a p. So I have rate with m minus p over p equals the m implied over 1. Flip when I divide. So p over m minus p. You cannot cancel these m's because this is a unit with a minus sign, so it's stuck together, can't be separated. So the final answer for the rate is mp over m minus p. And what was my rate in? It was miles per hour, so miles per hour, or you can write out miles per hour, just depending on how you wish to summarize it. Triple checking that answer. Oh, yep, there it is, bottom of the page. MP over, yep. All right, example 6 on the next page. The boat traveled k miles, same formula, distance k miles, in t hours, that's my time, and it was 40 miles short of the goal when the gun went off. The skipper tried again. How long would it take to reach the goal if she increased the rate of travel by 10 miles per hour? Do we know the rate of travel? Nope, they did not tell it to us in the first sentence. So we want to solve for this r, and that will be k divided by t. Now this is my new rate that I'm going to fill in, but I made a change to it. It said it was increased by 10. So we're going to add 10 to this to make the new rate k over t plus 10 in a unit. And it's asking for how long. Do not know the time. That's what I'm solving for. And was there any change to the distance traveled? No, it still needs to be k miles, and we're solving for the time. So we're going to put a common denominator of t. That means a t needs to be placed in the numerator. So altogether, this is k plus 10t over t with my time, implied k over 1, divide, flip it over, t over k plus 10t. Simplify, time is kt over 1 times anything, doesn't make any changes, 10t. All the parts do not share a t or a k, so there's nothing I can reduce. My time was in hours. And there is our solution. Now, they did not, one moment, why do we have a problem not matching? K plus 10t denominator is fine. K plus, whoa, did I misread something? Ooh, I did. I left out a piece on the very first sentence. Yikes. Let's fix that. The boat traveled K miles in T hours, but was 40 miles short. So when I got to here and I said, did I make any change to my distance? Yes. Only covering K gets me only not fully to where I need to be. I need to cover 40 more than that. So this should have been K plus 40 more. So let's fix that here. That's distributing. So T, well, they didn't distribute it. That's what I started to say when I looked at their answer. They didn't distribute. I'm going to go ahead and distribute here. T times K is TK plus 40T. That should be your numerator. And they wrote it as T parenthesis K plus 40. Same thing. Denominator is the same, and yes, it is definitely in hours. So you may, to avoid problems like mine that I just had, you may want to reread your problem and make sure that you did not miss any steps before fully solving the problem.